The problem says, using the data set above, fill in the following frequency table. We are going to write our classes in interval notation using the lower bound and upper bound with the brackets. So remember, that means we're including those values. And also our class width is going to be 0.5 with the first bin starting at 1.0. So first, let's talk about this class width. Remember, what does it mean to have a class width of 0.5? It means that the distance between the start of every single class is going to be 0.5. So if we're starting off with 1.0, we can put in 1.0 into the first one. Well, what is 0.5 above that? That means the next one is going to start at 1.5. And then the one after that is going to start at 2.0. So we're just going to keep adding 0.5 and counting by 0.5s all the way until we get to the last class. And again, they're all done with brackets. Oops. This will be 3.0. 3.5, and then lastly 4.0. So they're all going to be done with brackets because we're going to include that. Now, if we were using just the parentheses on the other side, then we could say this has a width of 0.5 because it goes from 1.0 to 1.5. However, since we are using the bracket instead, we want to think what's the highest value that's going to be in this bin, because 1.5 is actually the next bin. So since we're rounding everything to just one decimal place, well, what's the highest number that's not 1.5 but has one decimal place? That would be 1.4. So that's going to go up to 1.4. And same thing here. What's the highest number that's going to go, that's not a 2.0 that's going to fit in this bin? Well, that would be 1.9. And then close that off. And so we can see as we continue each of these, it's just going to continue that same pattern. 2.0 to 2.4, the next one starts at 2.5 to 2.9, and then we can finish off the rest of these. And then lastly, we have the 4.4. So now it's all about seeing our frequency here. So if we want the frequency, we have to count how many values fall in each of these bins. So let's just start off with the 1.0 to 1.4. Now, luckily, these are already all in order, so we can easily find this. This number right here is in between 1.0 to 1.4, so we only have a frequency of 1. Between 1.5 and 1.9, there's only this value here, 1.8, so there's only one value. 2.0 to 2.4, well, there's 1, 2, 3, then 2.5 is too high, so we just have a frequency of 3. And we'll continue for each of these. So 2.5 to 2.9, it looks like we have 3. 3.0 to 3.4, looks like we have 3. 3.4 to 3.9, it looks like we have 4. And then just 1 that goes into here. So the next part that we have to figure out is our relative frequency. Remember, relative just means we're turning this into a percentage or decimal. So we have to know how many values total there are in this data set. So we can either count it up or we can add together all the frequencies here. But I'll just count it. 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16. So if we have 16, then that means we're just going to take each of these and divide it by 16. So the first one for this line here, we're going to have, there's a frequency of 1 out of the total of 16. And if we just divide that on a calculator, this is going to get 0.0625. And so I can type that one in here. Then our next one is also 1, so that's going to also be 0.0625. Then we also have this line right here, which is 3. So let's figure out what 3 out of 16 is. And if we do this, we get 0.1875. And so I'll put that in there. Same thing with these next ones. The only one that looks like it's different is this one right here, which is 4 out of 16. So we just do it for every single line. And if we do this, we get 0.25. And so now that we have that, now we can actually put this into our table. All right, so I've typed in each of those. 1 out of 16 gives us this. 1 out of 16 gives us this. 3 out of 16 for each of these. 4 out of 16 and 1 out of 16. And there's our relative frequencies. Now, one way we can actually verify that these actually might be correct is if we add all these relative frequencies up, it should make up 100% of our values. So all of these should add up to 1. And you can verify that on your own. If you actually add each of these values together, you will see that it does come up to a total of 1, meaning 100%. Next, we have cumulative frequency. So what does cumulative represent is we're accumulating all the values that are less than or equal to that bin. So the first one is always going to be easy because it's only one value that's going to be less than or equal to this bin here. Then from there, we're going to accumulate everything up to those bins by adding. So for example, this next one, well, how many values are less than or equal to 1.9, or in this bin? Well, there's the ones that are already in there, which is the 1. But there's also one value that was in the bin that was lower than it. So both of these together are going to make together 2. And then we're going to just continue on. In this next bin, how many values are less than or equal to 2.4? Well, there's 3 in this bin, plus 1 gives us a total of 5 that are less than or equal to. So again, the cumulative just means less than or equal to. And we can continue this pattern for the next, for the rest of the table. So if I get 1 plus 1 plus 3 plus 3, it gives us 8. This next one is 11. Plus 4 more is going to be 15. And lastly, we have 16. So just like here, if I added all these values up, it would give me 1. The thing about the cumulative frequency is when you get to the very last and bottom row, it should represent all the values because all the values are going to be less than or equal to the highest bin. And there are 16 values, so all 16 values are going to be less than or equal to 4.4. And this should be it, right? We have the frequency, which is the counts, relative frequency, which means we divide and turn them into percentages or decimals, and cumulative frequency, which just means we're adding them up and accumulating to be less than or equal to those values. And there we go.